Hi everyone, I think we're ready to start, and today's topic of our Cambium College is applications. And it is the third part of our applications class. And the topic today is streaming video and throughput, uplink and downlink. So what we're going to cover today is streaming video in the uplink direction, which means from the subscriber side to the base station, and it is usually video surveillance, also known as CCTV, and streaming video from the downlink to down to SM, so from access point to the subscriber model, and it is usually IPTV. Those topics, CCTV and IPTV, they have a lot in common because they share the same similar set of protocols, and during the presentation I will show you. So let's start with the IPTV. What IPTV is, and right now there are different technologies behind IPTV. There is a regular IPTV, similar to traditional cable systems, and it is usually provided by your internet service provider or just some telecom. And on other side of IPTV, there are video on demand services like Netflix, Hulu, Amazon Prime Video, and this type of services. So what I would like to do today is to focus on a traditional IPTV, which is similar to the cable-like TV transmission system, because video on demand services like Netflix, they look like traditional HTTP traffic while you're serving data. So IPTV, the similar one to cable, it is using the same set of internet protocols like HTTP, which is Hypertext Transfer Protocol, IGMP for Multicast, traditional networking protocols. But it also using the specific protocols like RTP and RTSP. The main difference between them that RTP is using UDP mainly as transport protocol, underlying transport protocol, and RTSP is using TCP. So why IPTV over wireless? Because here in Cambium, doing Cambium College, we're talking about wireless. So why IPTV over wireless and not traditional cable? First of all, it can be two-way data flow, and there are services and service providers providing intelligent set-top boxes that can give you additional features like video on demand, set-top box like DVR functionality, so you can record your favorite show. And in order to implement these features, you need this two-way data flow. Another thing is with IPTV over wireless, having this two-way connection, you can provide way better personalization. One of the operators I know can personalize based on your location and show you specific ads. So as soon as operator knows your specific geolocation, it can show you targeted ads for specific, for example, car dealerships around you. So you will see only local ads, but not the global ads. Again, with the two-way connectivity and wireless, you can make this kind of stuff. Another good thing about IPTV over wireless, you can just use your existing infrastructure. So you don't have to build your own cable. You don't have to use satellites or anything like this. You can just reuse your data infrastructure you use for internet access to do IPTV. So what kind of protocols is used in traditional IPTV scenario? First of all, it is SDP over HTTP protocol, which is used to get the list of channels. So using SDP and HTTP, your set-top box can get the list of available channels by your provider. So it knows where to go. I mean, the set-top box knows that if you go to a specific URL, you get the list of all available channels. And then you have two different options. The first one is use RTSP, which is TCP-based protocol with the acknowledgements and with the bandwidth control and stuff like this. Or you can use RTP, and if you want to do multicast, IGMP, and it will be UDP-based protocol. The different ways of delivery, I will describe it later, why you want to use multicast over the TCP, which is Unicast transfer. But those three protocols, they are the most popular to deliver IPTV. RTSP and both actually RTSP and RTP supports some meta information and some control plane, so the customer can play, pause, record, and send other control information from the set-top box up to the streaming server. So video on demand. Again, using wireless as your solution, or it can be Ethernet or any bidirectional connection, two-way connection. It is easy to stream video on demand. So you can you can send Unicast stream to specific set-top box with the on-demand video or show. So codecs, what means codecs? This is the way how you compress the data. And there are multiple codecs, and probably the most popular nowadays is H264. It is the top one, and it is used for most of the video transfer nowadays, from starting with YouTube and Netflix and ending with all IPTV or CCTV solutions. So for the delivery, and this makes those protocols, RTP, RTSP, and the codecs inside this data flow, like H264, makes both IPTV and CCTV very common, because they both use the same set of protocols and the same codecs inside of the traffic flow, which is H264, for example. The only difference between IPTV and CCTV in this case will be the direction of this video flow. One is going downstream, downlink from AP to subscriber, and another one is from subscriber up to the base station and then going to the NVR or DVR or any other type of equipment. So speaking about CCTV, there are two competing standards right now. One is Physical Secure Interoperability Alliance, and as you see, it is using the same set of codecs as IPTV, and the same streaming protocols like RTP over UDP, RTP over RTSP, which is TCP, and etc. And another protocol which is open protocol, open stack of protocols, and there are open source implementations of those standards. It is called Open Network Video Interface Forum. And again, there are the same codecs. There are additional audio codecs and the same streaming protocols and additional joystick PTZ to control your PTZ cameras. So those two sets of two different protocols are supported by one vendor or another. Some of CCTV camera or DVR vendors support both of them, so you can choose which one you prefer. And if you have a mix of CCTV cameras from different vendors, you have to check which one you want to use. So H264 is the standard number one used worldwide for everything video related. It is very high quality, offers consistently good video, even with a low bit rate, so you can enjoy your new TV show even using the cellular coverage somewhere in Siberia. It is very error resilient, and again it makes it a good fit for wireless, because having interference, having packet drops can cause issues in video, and it helps to recover those errors and show you the best picture. And H264 is network friendly, so it can be transported on top of any kind of transport protocol, RTP, RTSP, HTTP, all kind of transport protocols. So coming to the topic of multicast versus unicast, and you can see the diagram on the screen. The top one shows the multicast delivery. On the left side, you can see the streaming server sending IPTV data down to the customers. And with the multicast, the specific IPTV streams going to the subscribers subscribed to these specific streams. So subscriber have to subscribe to the multicast stream to receive it. And multiple subscribers can subscribe to the same stream, and this data will not be multiplied to each and every customer, but it will be sent as a one batch down. With the unicast, each subscriber will receive its own stream, so they will not share one stream of data going down. Each of them will receive its own stream. So the multicast is one-to-many relationship, so one streaming server sending one stream to many subscribers. With the unicast, it is one-to-one relationship. So one streaming server sends one stream to each subscriber. Even if it is the same stream, it will be sent multiplied by number of subscribers wanting to watch this specific channel. So multicast, it has some pros and cons, as well as unicast has some pros and cons. So the pros for multicast, it can save some throughput, especially with your backhaul or your core network throughput, because you will send only stream which is that is needed to specific subscribers if they are really watching it. And if multiple subscribers are watching the same stream, you will send it only once. with the Unicast. So this is the pro for the multicast. What are the cons of multicast? The cons of multicast that usually multicast is sent without acknowledgements. So the streaming server doesn't know anything if the IPTV data, video data, was delivered to the end station, to the set-top box. There is no way to set-top box can send acknowledgements for the multicast data. It means if you have non-reliable network with the packet losses, if you have interference in your wireless network, you will see drop in picture quality, in the video quality. Because of this, you will see pixelization. So this problem is solved by sending the data in Unicast mode, one-to-one. So streaming server sends unique stream to each and every set-top box. In this case, set-top box can send acknowledgement if the data was received. And if it was not received, set-top box can retransmit this data. So there is a way to recover all the packet losses that can occur on the way from streaming server to the set-top box. So what are the main IPTV challenges in the wireless? So the first challenge is transport protocol itself. So the RTP protocol, it is using UDP as an underlying transport protocol underneath it, especially with multicast delivery. So it means there are no acknowledgements. There is no state of connection between the streaming server and set-top box. In case interference, low signal level, if there is any kind of congestion in the network causing packet drops, if the customer is using, for example, surfing Facebook and consuming a lot of bandwidth, we can start dropping those packets and they will be never recovered. I mean IPTV packets. So the only way to solve it is to use other protocols like RTSP. Now let's try to think what we as a wireless vendor, what we do to guarantee IPTV delivery and CCTV delivery, any kind of video delivery in our systems. As an example, I have our ePMP system, and the main thing we are using to guarantee best IPTV quality is quality of service, QoS. And one of the key features for the IPTV we do with wireless solution called ePMP. So we bring wireless over long distance, as you probably know from our previous college sessions. So let's talk about QoS. I will come back to this slide later on. So the rate adapt algorithm and QoS. What is rate adapt algorithm we use in ePMP? Rate adapt, it is the way how we deal with packet losses due to interference, due to changes in the signal noise ratio. So how we change the modulation scheme to send data. So you can imagine we're going on the highway with a high speed. Then we go forward and see the traffic jam. So we have to go downshift if we have a manual stick. So we have to go downshift. And the way we do upshift and downshift on our gear and our car, it can increase our average speed. If we do it fast, we will move with a very fast speed. The same with the rate adapt algorithm for video. So we want to transfer IPTV packets in the air. And if we can do it fast and reliably without crashing in the traffic jam, we will get the best performance. So the recommendation is to have loss than 3%. This is the recommendation from ITUR. Another thing which is key is not to lose iframes. There are different types of frames in the H264 codec. iframe, which is also known as a key frame, and there are BNP frames, which are constructed around those iframe. So if you have iframe lost, you will lose information on the upcoming BNP frames, upcoming 14 frames. So it will impact 15 frames, and it will probably be noticed by your customer. So with ePMP, we are trying to do the rate adapt as best as we can. So no iframes will be lost, and to have the consistent packet loss lower than 3%. So quality of service over the air priorities. Over the air, we have, when we build ePMP, we build it with the idea of triple play, and it applies to all our equipment we do in Cambio. Triple play means voice over IP, IPTV, and data. This is why, for example, in ePMP, we have 3 levels of priorities. The highest priority level, which is voice over IP. The medium priority level, which is called high, usually used for IPTV or management. And we also have lowest priority. It is the default level of priority, and all the data, internet, surfing usually goes to the low priority queue. Between those priority queue, we have so-called weighted fair queuing mechanism. Depending on those 3 queues, they have different weights. Obviously, the highest priority queue has a higher weight compared to the medium and lowest. And what else we have in terms of quality of service? And it applies not only to our own equipment, it also applies to other equipment in the market. So Unicast traffic can be assigned to a certain priority level out of those 3 using different filters. So you can create custom layer 2 or layer 3 filter, so you can capture this traffic and assign the priority, and those packets will go to specific priority queue. You can also prioritize broadcast and multicast traffic, and it can go to high or to low priority queue accordingly. Another important option we have, it is called SM priority, or subscriber model priority. There are 3 levels of priorities: normal, high, and low. And the idea is, if you have a VIP customer or some subset of customers using the latency specific, latency intense applications like online games, you can prioritize all the traffic going from them with the setting the highest priority to the RSM. With the ePMP, we also created the automatic QoS rules. It means that we can automatically detect multicast, and if we use multicast to deliver IPTV, it will be automatically prioritized. But you can also create all types of custom rules, and if you deliver IPTV, it is always a good idea to prioritize it based, for example, on the VLAN. And many ISPs delivering IPTV, they have a dedicated IPTV VLAN. So very easy to prioritize. You can prioritize it using VLAN ID on your subscriber model, on the access point, on your router, on your switch, on your core router. So everywhere from the streaming server down to the set-top box, you can prioritize it. And obviously you can use IP and MAC addresses if you want to prioritize. This is the typical web interface from ePMP. This is how it looks like. So you can create the QoS classification rules, custom ones, using all those parameters I described, like VLANs or 802.1p, priorities, or IP addresses, MAC addresses, so anything you wish. So reliable multicast with ePMP. In ePMP, we have a special mode for multicast delivery called reliable multicast. And when I was talking about IPTV, in a typical video streaming solution over wireless using multicast, you will see the whole picture, the following picture. So the video streaming server sends the video data to the multicast router, then it comes to the access point, and we don't have the wireless switch here, right? We have air, we have wireless. In this case, access point will send this multicast data as a broadcast to everyone. In order those subscribers can receive this data, we have to send it at the lowest modulation. So all of them, no matter of the distance, no matter of interference level, all of them can receive it. And the problem is that there are no acknowledgements from those subscriber models coming back. With the IGMP snooping and with the IPTV delivery using multicast, and with the reliable multicast turned on the access point, it turns the IGMP snooping on. So access point will convert the multicast data coming from the multicast router. It will convert it to Unicast on the layer 2. It will send it to the subscriber model only subscribed to this specific channel. So if someone is watching CNN and it is only the host one is watching CNN, so the access point will convert CNN to the Unicast, send it to the subscriber model number 1, only to number 1, and that's it. The best thing about it, it will be sent with the modulation used for the subscriber model number 1, the best one. And there will be acknowledgement sent. There will be automatic bitrate control working. So the auto bitrate I was describing before will work. If someone else tries to watch CNN and turns the CNN channel on the set-top box, the access point will create another Unicast channel to this specific SM. So we will send CNN twice, to the subscriber number 1 and to the subscriber number 3. But again, the good thing is it will be reliable. With the acknowledgements, if the interference pops up, we will do the retransmission and it will be delivered. So this is the way how you can solve problems of multicast delivery if you have IPTV multicast in your network in wireless. So ePMP is our last mile solution. The way how you connect end customer homes. But inside the home, the customer can have Wi-Fi. For example, CN Pilot. CN Pilot is Cambium's Wi-Fi product line. And on this level, there are also some tricks that can help with the IPTV delivery, because the customer can have the Roku connected via wireless to the Wi-Fi access point. So what we can do with the CN Pilot, we can configure WAN access, multiple WAN access, and we can set up dedicated VLANs for the IPTV and for voice. So if you have different VLANs, you can terminate those different VLANs for voice, for IPTV. You can terminate those VLANs on the CN Pilot. So you don't need additional router. All those VLANs will come from the ePMP, for example, to the CN Pilot. And you can terminate them and provide the IPTV service or voice service to the customers connected to this CN Pilot Wi-Fi access point. So as I said, CN Pilot supports so-called multi-WAN connection. So you can split different types of traffic based on the VLANs. And you can do the bridged connection, routed connection, netted connection, depending on those VLANs. And it can support even different SSIDs for those services. So at this point, that is it. I have to discuss about upstream, uplink, downlink, video streaming. If you have any questions, you can write them down in the question box. I will try to answer them right now. If you have any, and they can be not only video related, anything you have in mind, just ask. So I have a question regarding the PMP 450 and if it does the same for IPTV. The answer, yeah, 450 is pretty advanced platform, and it can do a lot of enhancements for the IPTV. It has very advanced quality of service, and as for ePMP, it is an integral part of quality of the scheduler. So the prioritization is an integral part how you schedule packets sent in wireless. The same applies for the multicast. There are lots of settings you can set up multicast transfer on 450. So the answer is yes. Okay. It seems, oh, another one. It was a comment thanking me for the screenshots. If you have any questions, please feel free to go to our community forum, to our Cambium community forum, and we will be always happy to answer your questions or your concerns. If you have any ideas about Cambium College or Cambium in general, please feel free again to go to our community forum and post it in the ideas section. We are always happy to implement new ideas, and I myself very passionate about the ideas coming from our clients, our people watching our videos, listening for our webinars. So thank you. And the last but not least, please join to our Facebook pages, to our Twitter account, and all other social media you're using. We are posting a lot of cool stuff there. So thank you.